Maybe people would understand more what we're talking about, and then we can follow up. You
Okay.
have Logo loaded, and show us what it is.
I have Logo up and loaded. There are a couple of components to Logo, and maybe I should fill in a minute or so of background before going to the demo.
Sure.
There are two main components. One that's very well known is called Turtle Graphics, which has to do with displaying things on the computer screen. That's what I'll be showing, and that's what's widely used with kids. There's a whole second component called list processing commands, which enables you to use this programming language to work with words, sentences, numbers, and other types of things. But it's the Turtle Graphics commands that have really been widely used in education. What we have in Turtle Graphics are some very simple commands that kids can learn easily. You can tell the turtle to do things like move forward a certain number of turtle steps, turn right or left a certain number of degrees. The turtle has a pen. It can lift the pen up or down. If the pen is down, it can draw things as it goes. The idea of Logo is that these simple commands can be combined into what we call procedures, and very complex programs can gradually be built up among a number of procedures. What I have already loaded in the computer is one example procedure, which is a simple one, but one that can do a number of interesting things. The procedure has been given the name Magic, and Magic requires that we tell the turtle we want to use Magic, and we give it 4 numbers so that it knows what to do. And as a sample, we can start out with the numbers 20, 90, 10, and 8. If we do that, the turtle will draw us a little picture. What the numbers are telling the turtle to do, the first number is the length of the first line. The second number, 90 here, is the angle for the turtle to change, to turn. So we'll see we have right angles here. We can also see that the length of each line the turtle has drawn increases as we go on. The third number is the increment. Okay, so the first line was 20, we increase it by 10, the next one's 30, the next one's 40. The final number, 8 here, is the number of turns for the turtle to make before stopping. Okay, so it's a simple procedure built up of forward and right and repetition. Okay. The interesting thing about this particular procedure is we can get very different kinds of pictures just by changing the numbers. So here I'm changing the starting line, the increment, and the number of turns, but I'm leaving the angle at 90 degrees. Okay, we get a little more intricate, interesting picture. Now what happens if we just change that angle? So let's use the same starting number, increase the angle to 135, same increment, same number of turns. Okay. Now we have a star-shaped picture, a very different type of image just from changing the angle. So one kind of thing that Logo is designed for is to lead kids to explore the computer, explore what will happen with these kinds of forms, and children can just get a feel for what angles are, how you can build up different pictures by typing in different numbers and seeing what will happen. Okay. There are some more I can show if we have a few
go ahead,
more minutes.
yes. Just show us another.
Okay, let's just make another change in the angle.
Still doing Magic, though? Here?
Still doing Magic, if I typed it correctly. Changing the angle and changing the number of turns that the turtle makes. Yeah. Here we have a much steeper angle and another very different picture. Now let me show you what the procedure itself is. We can have the computer list the procedure. This is the entire program that we're working with. The first line simply says to the turtle, we're going to tell you how to do the Magic procedure. We're going to teach you a new word, in a sense. The Magic procedure uses these 4 numbers, which we're calling start, angle, increment, and end for number of turns. The first thing the turtle does is go forward, the number of steps it's told to by start, turns right, the angle. We then say, if n equals 0, stop. What we're doing here is we're setting n to a number. The turtle will count down till n reaches 0, and it will stop there. The last line of the program is really the powerful line. It says, do Magic again, but do it with the line changed by the increment and with n being 1 less. Okay? That's what's called a recursive command. The Magic procedure is repeating itself, changing as it goes along. That's the entire program that created that variety of pictures.
Okay, Glenn, it's kind of interesting and it's fun to see all those pictures, but it seems a bit whimsical in a way. I mean, what's the big deal?
It is perhaps whimsical in a way. Kids enjoy whimsy. I think the big deal is that it's a very different approach than the kinds of things Professor Suppies was showing. Professor Suppies was showing computers really used to do the kinds of things we've always done in education, to do tutorials, to do drills, and certainly that's a valid use of computers. Logo is widely cited as an example of doing something new with computers. introducing an environment, a tool that kids can explore, where the child has more control than the computer. Here, it's not that problems and questions are coming out of the computer's waiting for the child to respond. Here, the child has complete control of the situation.
Pat, what's your observation on this use of a computer as opposed to what you're doing?
Oh, I think that the use of Logo could be valuable and fascinating for young students. I think that in teaching students about computers, the nice thing about Logo is they get a quick and easy sense of how a computer language works. That doesn't mean, for example, that I think that's the only use, obviously, but I think it's quite an acceptable and valid use.
Are there social or perhaps antisocial consequences to coupling kids with machines rather than kids with traditional flesh and blood teachers?
Well, I think we want to differentiate cases. In the elementary school, it's very important to have a relationship to a teacher. One of the paradoxes of American education is that the data are overwhelming. That's the way it should be, and yet class size on average is larger in elementary schools than in secondary schools. As we get to older and older students, let's say out to adults, then we're in a different kind of world. Many adults, for example, in the future may want to get a good deal of their education at home over a terminal because it's inconvenient to go to a campus site.
You do see, as you mentioned in your own course, the possibility that an entire course or maybe curriculum would be taken by a mature student via computer.
Sure. And my own courses at Stanford are meant to be an example of that. And that could well be a course in programming. I mean, as far as it's very similar to teaching logic that way. But the socially important thing is you can teach courses that way. So you can have a decentralization, and it's really a social decision and an administrative and psychological decision, not a technical decision.
Okay, real quickly, Glenn.
I think I have a somewhat different view. I view the computer as a tool for the teacher to use. I certainly don't think computers are capable of replacing teachers. I, in fact, was a student in Dr. Suppi's course the first year it was taught by computer, and I found that the computer is a good means for practicing logic, but I think there's an elegance to logic. There's intuitions about logic. There's information about how formal logic relates to general problem solving that one could get from a professor like Dr. Suppi's better than any computer program.
Gentlemen, I'm afraid on that